Hey y'all, so today we're going to discuss lesson 2-5, solving literal equations for a variable. So we're going to continue solving equations by following the steps that you need to follow. Let me get my pen here. But now you're going to notice that there's multiple variables. Okay? So that's what we're going to do. We're going to solve, whoops. I clicked the pen and then I clicked off it. All right, here we go. We're going to solve literal equations for a specific variable. Okay, it will tell you the variable to solve for. So for a specified variable, we're going to use a formula that has been solved for a specific variable to determine an unknown quantity. Okay, so a formula, the definition of a formula describes how two or more quantities are related. Formulas are important in many disciplines. Geometry, physics, economics, sports, and medicine are just a few examples of fields in which formulas are widely used. A formula is an example of a literal equation. A literal equation contains more than one variable. Keyword here, more than one variable. More than one variable. Okay, that's what a literal is. Literal equations and formulas can be solved for a specific variable. Okay, keyword, specific variable, using the same procedures as equations containing one variable. Okay, you follow the same steps. Over here in the math terms, a literal equation has more than one variable, and the equation can be solved for a specific variable. Again, specific, it will tell you. Formulas are examples of literal equations. A formula is an equation written using symbols that describes the relationship between different quantities. So let's look at an example of a literal equation. Okay, if you look at this equation, it looks a little different than what we've been looking at all week here. Okay, we have 4x plus b equals 12. We have a variable x and we have a variable b, but it tells you a specific variable to solve for x. So at the end, our equation should read x equals an expression over here, okay? And your expression will contain the variable b. It will contain the variable b. Okay, so if you follow those steps, isolate the term that contains x by subtracting b from both sides. So in the previous equations, there would have been a number here. There would have been a constant plus, 2 or 3 or whatever, and we would subtract that number. Well, because we have a variable b, we would just subtract b from both sides. Okay, subtract b from both sides. When we do that, we get 4x equals 12 minus b. You can't subtract b from 12 because we don't know what b is. So we're just going to have our expression 12 minus b. 4x equals 12 minus b. In previous equations, how would we isolate the variable x? How would we essentially get rid of that 4? Well, in order to isolate the variable x, you divide both sides by 4. Divide both sides by 4. When you do that, you get x equals. That's what we wanted to do. You get x because we're solving for x. X equals the expression 12 minus b divided by 4. And that is your answer, 12 minus b divided by 4. Now, in your book, you can scroll down here, and you'll see that you can leave it as x equals 12 minus b divided by 4, or you can simplify to get 3 minus b over 4. And that's just dividing both terms, 12 and negative b by 4. 12 divided by 4 is 3. Negative b divided by 4 is just negative b over 4. Both of these answers are correct. This is just the simplified version of 12 minus b divided by 4. Okay, now I'm going to come over here and I'm going to do it the vertical way in case that confuses any of you. I'm going to do it the way that I was doing it in the previous lessons. This is solving equations vertically. This was horizontal. The example is horizontal. This is vertical. Subtract b, I get 4x equals 12 minus b, divide by 4, and then I get x equals 12 minus b divided by 4. Okay, the simplified version of that. And I'm going to write this down here so that you can see. If you can't visualize it, here you go. X equals 12 divided by 4 minus B divided by 4. And that's how they got the X equals 3 minus B over 4. That's where that comes from. Okay? Now I want you to take a second and I want you to pause the video and I want you to do A, B, and C by yourself and then come back and watch me do it for you. Okay? Now that you have paused the video and taken a second to do it yourself, I'm going to work these problems for you. Okay? So I'm going to write A in red in case my work starts jumbling together. AX plus 7 equals 3. Well, I'm going to subtract 7 from both sides. When I subtract 7 from both sides, I get AX equals negative 4. Now I'm solving for what variable? We're solving all of these for x. It's saying solve all for x. If I want to isolate x, I'm going to divide by a. I'm going to divide by a. So x equals negative 4 divided by a. Again, follow the same steps. Okay, so that was A. Now I'm going to change my colors and I'm going to do B. Ooh, I like this lime green. I haven't written in lime green yet. Let's see if that shows up. All right, so now we've got CX minus 10 equals negative 5. We're solving for X, so in order to isolate the term with the variable, I need to add 10 to both sides. I need to add 10 to both sides. Now I get the term with the variable set equals to 5. Now I need to isolate the variable. In order to isolate the variable x that I'm solving for, I need to divide both sides by c. So x equals 5 divided by c. Okay. Now I'm going to write in purple. All right. Now I'm going to write in purple. Negative 3x plus d equals negative 9. Okay, now I'm solving for the variable x, so I need to isolate the term with the variable x. In order to do that, I need to subtract d from both sides. When I subtract d from both sides, I'm left with negative 3x on the left side of the equal sign and negative 9 minus d on the left. Now I need to isolate the variable x because I'm still solving for x. I'm going to divide both sides by negative 3. When I do that, I'm left with x equals negative 9 minus d divided by negative 3. Now, you can leave your answer like this, or you can simplify. I would prefer for you to simplify, but if you have trouble, that's fine. Okay, in order to simplify this, you're left with x. That looks funky, doesn't it? Let's try this again. We are left with x equals negative 9 divided by negative 3 and d divided by negative 3. Okay, now when you have a negative and a negative, that turns to positive. Okay, so negative 9 divided by negative 3 and negative divided by a negative is what? A positive. So now we're left with positive 3 plus d divided by 3. They all change to positives. 3 plus d divided by 3. Okay. All right, so now we're moving on to what page is this? 29 in your book. I want you to take a second, pause the video, do your check your understanding, and you're going to submit that as classwork. Now we're at another example. Example B. The equation V equals V sub 0 plus AT gives the velocity in meters. That's the velocity formula in meters per second of an object after t seconds, where V sub 0 is the object's initial velocity in meters per second, and A is its acceleration in meters per second squared. Connect to physics. An object's velocity is its speed. Okay? If you ever hear the word velocity, it means speed in a particular direction. And acceleration is the rate of change in velocity, the rate of change in speed. Okay? You should hear acceleration when you're driving a car. Okay? Most of you are learning how to drive cars right now. So when you hear the word accelerate, that means you need to change your speed. Either slow down or speed up. Acceleration, slow down, speed up. If an object has a positive acceleration, it is speeding up. If it has a negative acceleration, it's slowing down. Okay, so part A, solve the equation for A. Okay, there's our specified variable. Solve this equation for A. So we need to isolate A. We need to get A by itself. Excuse me. Determine the acceleration for an object whose velocity after 15 seconds is 25 meters per second and whose initial velocity was 15 meters per second. Okay, so let's focus on A. Solve the equation for the variable A. Okay, so we have this original equation, V equals V sub 0 plus AT. And again, we're solving this equation for the specific variable A, specified variable A. So if you have V equals V sub 0 plus A times T, you want to isolate the term with the variable A, which is the AT. We want to isolate this term. In order to do that, we need to subtract out V sub 0 from both sides. We're going to subtract out V sub 0. So then we're left with V sub 0 on the left side. V minus sub 0 equals AT. We've isolated the variable or the term with the variable A. Now, in order to isolate the variable A, we need to divide both sides by T. Divide both sides by T. And when you do that, you are left with V minus V sub 0 divided by T equals A, which is what we wanted. We wanted to isolate the term with the variable and then isolate the variable A. So in order to determine the acceleration for an object whose velocity after 15 seconds is 25 meters per second and whose initial velocity was 15 meters per second, you substitute in 25 for V because it tells you the velocity after 15 seconds is 25 meters per second. So V equals 25. So substitute in 25 for V. 15 for V sub 0 after 15 seconds. V sub 0 is 15 seconds. And whose initial velocity, I had that wrong. I had that backwards. V sub 0 is the initial velocity. I'm sorry. Initial velocity was 15. The time is 15 seconds. 15 for T. Okay, so 25 for V, which is the velocity. 15 for V sub 0 because that was the initial velocity. And then 15 for T because that was your time. When you substitute in those values into that equation that we just solved, you get 2/3 meters per second squared. Okay, so hopefully you paused the video and you attempted this problem. Here's the explanation. The equation T equals 13P plus 108 can be used to estimate the cooking time T in minutes for a stuffed turkey that weighs P pounds. Solve the equation for P, then find the weight of a turkey that requires 285 minutes to cook. Okay, so we have this equation, T equals 13P plus 108. The first part of this question is solve the equation for P. Okay, so let's go over here. I should have enough writing space to do it here. We have T equals 13P plus 108. All right, so I want to isolate the term with the variable P. In order to do that, I need to subtract 108 from both sides. When I subtract 108 from both sides, I get T minus 108 equals 13P. Now, in order to isolate the variable P, I'm going to divide both sides by 13. Now I've got t minus 108 divided by 13 equals p. All right. Then find the weight of a turkey that requires 285 minutes to cook. So if I know I only have 285 minutes before I need to have Thanksgiving lunch ready, what is the minimum pound of turkey that I should purchase? This is an example of why you would need to know this. Okay, so I'm going to change my color to purple here. So how big of a turkey do I need to buy if I know I've got 285 minutes? Well, when I simplify this, 285 minus 108 divided by 13 gives you 13.6. 13.6 equals P. What does that mean? 13.6 pounds. That's where this is, 13.6 pounds. So if you have 285 minutes, you need a 13.6 pound turkey or less. Okay. So now we're going to discuss number 3 that is on page 30 in your book. Number 3 is a table that has some formulas provided for you with the name of the formula, and it asks you to solve for a specific variable in that formula. Okay, the first one is a distance formula. D equals R times T. Distance equals rate times time. Okay, all right. So this is a common formula that you use. Distance equals rate times time, where D is the distance of an object travels, R is the average rate of speed, and T is the time traveled. Okay, so over here to the right, it says solve for R. Solve for R. Solve for the specific variable R. So in D equals RT, if I want to solve for R and isolate the variable R in this formula, I divide both sides by T. When I divide both sides by T, I'm left with dt equals R. D divided by T equals R. So let me rewrite that. R equals D divided by T. Okay? Now in the pressure formula, P equals F divided by A, where P is the pressure on a surface, F is the force applied, and A is the area of the surface, they ask you to solve for the variable F, force. So when I have P equals F divided by A, and it asks me, hey, solve for the specific variable F, I'm going to multiply both sides by that denominator, A. When I multiply both sides by A, my A's cancel and leave me with F equals A times P. So F equals P times A. Same thing. Okay, that's where that comes from. All right, now kinetic energy. K equals 1/2 mv squared, where K is the kinetic energy of an object and m is its mass and v is its velocity. Okay, I'm going to scroll down a little bit more here, but not too much. All right, so now if I have K equals 1/2 mv squared, and it asks you to solve for the specific variable m, I'm going to isolate m. In order to do that, I need to multiply both sides. I'm going to isolate mv squared. I'm going to eliminate the 1/2. In order to eliminate the 1/2, when you have a fraction, if you multiply both sides by the reciprocal, they eliminate. So 1/2 times 2 over 1, which ends up just being 2, right? So I'm going to multiply both sides. I'm running out of room here. 2 over 1. I get 2k equals m. Well, hold on. Let me erase that. 2k equals mv squared. Okay, so now I need to isolate v. Nope, we're solving for m. I'm sorry, I need to isolate m. In order to isolate m, I'm going to divide both sides by v squared. Divide both sides by v squared. When I do that, my v squared is eliminate on the right. And I'm left with m equals 2k divided by v squared. All right, now I'm at the gravitational energy. U equals mgh, where U is the gravitational energy of an object, m is its mass, and g is the acceleration due to gravity, and h is the object's height. I ask you to solve. No, I didn't need to do that either. I meant to grab the page. There we go. I need to solve this equation for the specific variable h. So if I have u equals m, g, and h, m times g times h, and I want to solve the variable h. Let me move this down a little bit more. I'm solving for the specific variable h. I need to divide both sides by m and g. If I divide both sides by m and g, my m and g's are going to cancel each other out, and I'm left with h equals u divided by mg. H equals u divided by mg. Now the last one, P1 V1 equals P2 V2, where P1 and V1 are the initial pressure and volume of a gas, and P2 and V2 are the final pressure and volume of the gas when the temperature is kept constant. Ask you to solve for the specific variable of V squared. V squared, right here. All right, so I've got P1. Here, I'm just going to write it up here, because this one's super easy. I've got P1, V1 equals P2, V2, and I want to isolate V2. Well, if I divide both sides, need my pen, don't I? If I divide both sides by P sub 2, I'm left with V2 equals P1, V1 divided by P2. Okay? All right, so I want you to do number 4 and 5. Check your understanding. That's part of your classwork. And then I want you to do lesson 2-5 practice, number 6 through 10, as your homework, and submit that on the Google form.